In this video, we're going to talk about the transition metals, and we're going to compare them to the Group 1 metals. The AQA specification says that he wants us to do that. So there's our periodic table, and of course our Group 1 metals are over here on the far left-hand side. Okay, there's Group 1, and they're in Group 1, and they've got 1 electron in their outer shell. Okay. Now, just to remember, this staircase line separates the metals from the non-metals. So everything to the right of that is a non-metal. So we have this big group in the middle here, which are, and that's what the transition metals are. Okay. And if you notice that they don't, that's the transition metals, they don't have a group number like 1 and 2, so you can't you don't really talk about how many electrons are in the outer shell of transition metals. Their electronic structure is a bit more complicated than that of the other elements we've looked at, and you don't really cover it till to A level. Anyway, the transition metals that AQA want us to look at are these ones up here. So that block: chromium, manganese, iron, cobalt, nickel, and copper. Okay. Now, they're used to exemplify all the other transition metals. You know, you will be familiar with a lot of other ones. So, for example, there's silver, there's gold, there's platinum, zinc. You'll be familiar with, probably heard of mercury, and so on. But we're just going to concentrate on those ones in green there. So, anyway, if we look at the Group 1 metals, they all have got 1 electron in their outer shell, and when they react, they all lose 1 electron to form positive ions, +1 positive ions. So lithium, sodium, potassium there. Right, with the transition metals, they form positive ions as well because they're metals, and that's sort of chemistry definition of a metal really, is something that forms a positive ion. Right, so that's where things can be a little bit different, because chromium usually forms 3+ ions, but it can also form Cr2+. Manganese most of the time forms 2+ ions in its compounds. Iron forms a lot of 2+ compounds and a lot of 3+ compounds as well. So forming variable valency is also a characteristic of transition metals. Of course, that never happens with Group 1 metals. Cobalt is nearly always usually 2+, but there are some 3+ compounds as well. Nickel, mostly just 2+. And copper, well, we know a lot of copper 2+ compounds, but there are also quite a few copper 1+ compounds as well. So that's another difference with the transition metals and this variable valency thing. Okay, so we need to know the transition metals are a lot less reactive than Group 1, a lot less reactive than Group 1. So I'll just move that down first of all. Let's talk about that in a bit. But what we want to talk about first of all, is the chemical properties rather than the physical properties. And as I say, that the Group 1 metals are much more reactive. So we want to see how they react with water. Right, with water, with oxygen, and with halogens, as exemplified by chlorine. Okay, so let's think about water first of all. Now, the Group 1 metals all react very vigorously with water. Take sodium as the example. So sodium and water, it fizzes up. It forms sodium hydroxide solution. That will dissolve, and that makes the solution very alkaline, pH 14, and we get hydrogen gas released. And in order to balance that equation, I need to put a 2 in front of everything except the H2. There you go. Right, lithium and potassium react in exactly the same way. Well, KOH, LiOH, they're both alkaline as well. That's another interesting thing, is we see that sodium hydroxide there is soluble in water. Most metal, all the other transition metal hydroxides are all very insoluble. And all group 1 compounds, practically all of them, are soluble in water, and that is a difference with transition metal things. They may be soluble, they may not be soluble. Right. All of those 6 metals, so chromium, manganese, iron, cobalt, nickel and copper, no reaction with water. With cold water they will not react. You can get them to react with steam sometimes, but with cold water, no reaction. With H2O they're much less reactive. Right, let's talk about the reaction with oxygen now. So oxygen in the air, you know that the group 1 metals have to be stored under oil because they're so reactive. They'll react with oxygen in the air, and you won't have anything left after a few hours. They all react very quickly, and I'll do sodium react with oxygen. They all form an oxide with that formula, Na2O, because they form a +1 ion, and so to balance that we need to do 2 there and a 4 there. Potassium and lithium do exactly the same. They will react very quickly. They'll tarnish very quickly in air. Now, the transition metals, they obviously, we all know that iron will rust very slowly in air. That takes months, okay? They react very slowly with oxygen in the air. So that's another difference, and it exemplifies the fact that they are much less reactive than the group 1 metals. Finally, let's talk about the reaction with chlorine. Now, all of the group 1 metals and all the transition metals, will react when you heat them. They'll react with chlorine to form the chlorides. Okay, so the group 1, they all form chlorides with the formula NaCl, whereas with the transition metals, it tends to be when they react with chlorine, they tend to react from the 2+, so you'll get iron FeCl2, you'll get MnCl2, and so on. But all of those metals, they will all react with chlorine. But having said that, the group 1 metals, the reaction is more vigorous because they are more reactive. Now, let's just talk about physical properties. Okay, so if I go over to that table I had here with density, okay? Now, the transition metals, they're all pretty heavy. They're quite dense. So you look at the densities there, they're all between 7 and 8 grams per centimeter cubed. They're pretty heavy things, metals are. Look at the density of the group 1 metals, they're much less. And don't forget that the density of water is 1 gram per centimeter cubed exactly for H2O. So that means lithium, sodium and potassium will all float on water, okay, because they've got a density of less than 1. Rubidium and cesium, they'll sink in water, but we don't really see them reacting with water very much because they're quite rare and they're expensive and they're difficult to store because they're so reactive and so on. But they're the group 1 metals are much lighter than transition metals. They're also softer. So with all of these, you can cut them with a knife very easily. They're all soft. They actually get softer as you go down the table, whereas we know that these metals, they're quite hard. They're difficult to scratch, and they're strong, and they're useful for making things out of because they're not very reactive. So we have like copper pipes. We use nickel in stainless steel. We use nickel in coins. Iron or steel is 99% iron. Most metal objects we have are actually made out of steel. So you can make things out of transition metals. Obviously, group 1 metals, you can't make things out of them because they'll just react away and you wouldn't have any metal left very quickly. So there's just the basic differences between group 1 and the transition metals.